All right, again, make sure you have your table of contents updated, not uploaded. So really all we should be adding is number 14 and number 15. Number 14 is what we did prior to the break. If you were here on that Friday before, there were 8 graphs that we walked around. Just looking at the graphs, we picked out their characteristics, and we're able to kind of choose an equation based on what we saw. If you were here and you participated in that, we did check it before you left, and I gave you a free 100 quiz grade. If you weren't here, it didn't count against you, but it certainly did not count for you because I was not going to give a free 100 quiz grade to those who did not participate. Okay? So, do y'all have any questions about kind of what happened that Friday before the break? Okay. All right, so table of contents done. Move that to the side. All right, very quickly, let's take a look at what we did prior to the break, just reviewing all of our characteristics. We talked about the parent graphs of all of our functions, x to the first power, right here, which is a linear function, through x to the fifth power. We have quadratic, cubic, quartic, and quintic, okay? What did we notice? We noticed there were some similarities in the graph of cubic and quintic, but what did we notice specifically happened that changed? What do I call that? A vertical stretch, that's right, okay? Now the higher the exponent, we should know that that graph is gonna grow a lot quicker, okay? I'm about to call names, and that will be on here for the whole world to hear, okay? We also talked about some other observations that we saw. If the power was even, we noticed that our tails were together, either pointing up or pointing down, and anytime it's odd, my tails are gonna be split. What do I call those odd shapes? What shape do I call them? S shape. Okay, and my even shapes can either be what or what? U or a W, okay? Can I tell with my quartic functions, just by looking at the function, what it's gonna do? No, that's why we like our graphing calculator, okay? All right, flip it over. Next, we talked about symmetry, the symmetry of functions. We have even functions who have symmetry about the what? The y-axis. And then we have odd functions, which are symmetric about the origin. Okay? That function, if we rotate it 180 degrees about the origin, then we'll have some rotational symmetry, and we know that that is symmetric. Okay? We can also look at just the equations. If all of my powers are even, we know it's an even function. If all of my powers are odd, we know it's an odd function, okay? And if there's a mixture of the two, for example, down here on n of x, okay, that was the last function, I have 5, 4, 3, 2, and 1. So I've got a combination of even and odd. What's that gonna do?
Neither.
Make it neither, that's right, okay? All right, then turn it over. We started talking about the end behavior. Now that's what my tails are doing on the left side of my graph and the right side of my graph, okay? We noticed that if it was even and positive, both of my tails pointed up. If it was even and negative, both of my tails pointed down. So again, even, they're together. Odd, notice they're going to be split. If it's positive, that tells me what's happening on the right side of my graph. So on the right side, it's going up. So that means on the left side, it's going down, okay? And if it's odd and negative, it's falling on the right side, which means it's going up on the left side, okay? Y'all kind of remember this stuff a little bit? Vaguely, okay? All right, let's keep going. We talked about those patterns. We wrote all that stuff out. Then we started talking about the zeros of my functions, okay? What are some synonyms for zeros? Solutions, roots, and x-intercepts. So any of those words can be interchanged. They all mean the same thing, okay? Now, it's a little tricky when you're putting it in the calculator and trying to figure those out. So let's do one as a refresher. We didn't do all the way through the last couple on this. So let's go to our graphing calculator, go to y equals, and whatever's there, let's clear it out, okay? All right, let's do m of x. Okay, so I'm going to do 0.5, and then I'm going to do parentheses, okay? So 0.5, I'm going to do x to the 5th power minus 20x cubed plus 64x, and I'm going to close off those parentheses, and I'm going to hit graph and see if it's going to show me what I need. It doesn't show me the whole graph, but can I see where it hits 1, 2, 3, 4, 5 times? Yeah, okay. Let's go to my window. Let's play with it a little bit. Okay, I think my x-axis is fine because I see it hitting all 5 times, but I kind of want to see a little more on the y-axis. Let's do negative 30 as your minimum and positive 30 as your maximum. Okay, let's hit graph and see what happens. Still don't see it all. If you want to adjust your window again, hit window. We could do maybe negative 50 and positive 50. That at least lets me see a little more of it, doesn't it? Oh dear, I'm sorry. Okay, now I see it hitting those 5 times. If I want to find my zeros using my calculator, what am I going to go into? Second calc. Okay, and what am I going to choose? 0. So number 2, okay? All right, now it asks me to be left bound. I like to start over here on the far side. So I'm going to arrow to the left. And notice right here, it's sitting on top of the x-axis. I want to keep moving to the left until it's underneath. I'm going to hit enter. And then I'm going to move to the right to answer the right bound question. And then I'm going to hit enter a 3rd time. And notice it gave me a pretty one. Did yours give you a pretty one? Okay. What did it give you? Negative 4, 0. Okay. All right. Let's go in and let's do it again. I'm going to do number 2. I'm going to move over to this 0. Notice this time, to be on the left side, it's above the x-axis. I'm going to move to the right side. So just hitting that arrow to the right and hit enter. Hit enter one more time. And I got another pretty one, didn't I? So negative 2, 0. All right, real quick, let's kind of go through these exponents real quick. I got 5, 3, and 1. So what do I know about this function? It's an odd function. So if it's an odd function, what do I automatically know it's going to go through? The origin. And since it has symmetry, what are my other 2 zeros automatically going to have to be? Positive 2, 0 and positive 4, 0. It's just going to be the opposites of what I had already gotten. Okay, so I had plus or minus 4, plus or minus 2, and 0. So that graph hit the axis 5 times. So that means all 5 of my zeros are real. And my degree to begin with was 5. Okay? Again, it's going to take some playing around with the graphing calculator, just trying to figure out what those zeros are, okay? If it gives you some kind of error, it might be because you reversed being on the left and right, okay? All right, flip it over. We kept talking about zeros, and then we talked about domain and range. What do I know for the domain of every single polynomial function? Negative infinity to positive infinity. It's all real numbers, okay? But for my range, I needed to address this idea of either a maximum or a minimum, okay? And that usually only happens with my highest power being even. Because what's true about my odd powers? My tails are, they're split. So there's no beginning or end to that graph, okay? It just goes on forever. So that brings us to critical points, okay? Critical points, critical meaning important, but specifically maximums and minimums, okay? They're gonna be high points and low points. It's also gonna be like our turning points. Do y'all remember we looked at the graph and we tried to find the U-shapes? How many U-shapes or turns there were, okay? All right, other points of interest in sketching the graph of a polynomial function are the points where the graph begins or ends increasing or decreasing. These points are called maximums and minimums. Now, I'm going to color code these. Any of my maximums are going to be green. And any of my minimums, I'm going to make pink. Okay? Okay, what does the word maximum mean? The highest. Okay, I hear you back there. Good job. Okay? All right, maximum points are located at the highest point that a graph reaches either overall or in a general area, okay? Notice in parentheses, I'm calling these something specific. If it's an overall maximum, that's going to be what we call absolute. What is an absolute? Something that is, okay, either the lowest or the highest, okay? So absolute means that's it, like, right? An absolute, if you think of like out of context of math, an absolute is something that is certain, okay? All right, so right here, a relative maximum or minimum, we'll get to that in a minute, is just in a specific area. It doesn't have to be the highest point overall, but it can be like a little mountaintop somewhere else, okay? Absolute maximums are the highest point on a graph overall. Relative maximums are the highest point a graph reaches anywhere on the graph, creating a peak of some sort. I generally refer to these as our mountaintops, okay? All right, minimum points are located at the lowest point that a graph reaches overall. Overall being absolute, or in a general area being relative, okay? Absolutes are the lowest point on a graph. Relative are where it just creates like some sort of dip, okay? And I typically call those my valleys. I've been calling them that for a couple weeks, okay? All right, it says for each of the functions, locate the turning points and related intervals of increase and decrease as you have determined previously for linear and quadratic polynomial functions. You will write the x values for the intervals, but you will look at the y value to determine if it is an increase or decrease, okay? All right, so let's look right here. What is the degree of this first function? 2. All right, what is the degree of h of x? 3. k of x and n of x. Okay. Now, what did we say about how many turning points I could possibly have? What's the maximum number of turns I could have for this one? Only one. Remember, my turning points, I will have n minus 1 maximum turns. Does that mean I have to have that many turns? No. Okay? Let's check out my graphs one at a time and see if that happens. Okay? So I'm going to go to y equals, and I'm going to type in my function. I have x squared minus 2, and I'm going to hit graph. Now, remember, I just played with my window. How do I get it back to my standard window? How can I do that? Zoom and number 6. Perfect. Okay? All right. How many turns do you see? How many U-shapes do you see? Only one. Okay? All right. So, what we need to do here is we need to determine what this is going to be. Is this a maximum or a minimum point? Minimum. Okay? So let's go in real quick. We kind of played with this before the break. Let's do second trace. And we're going to choose number 3. I want to be on the left side of the valley. It does not matter where. Hit enter. And then I want to go through the valley and get to the other side. And I'm going to hit enter somewhere over here. Again, it does not matter where. Everybody needs to have their calculator in their hand working this out. Okay, and my guess, I'm just going to hit enter one more time. Look at what mine did. Did yours do this too? What did we say that we're going to assume that that is? 0. So I have a minimum at the point 0, -2. Okay? Now, it was very specific just a minute ago. It says you will write the x values for the intervals. Okay? So for my x value right here, I need this point. You don't need a highlighter. I'm just doing this for us. I'm sorry. There you go. All right. So how do we read a book? Left or right? So how do I read a graph? Left or right? So from left to right, I'm going from -infinity to +infinity, right? Okay. So as I begin my intervals, what is this graph doing first? It's decreasing. So decreasing is what happens first. So it decreases from -infinity until I get to where? 0. And then 0, -2 is my turning point. So at 0, it turns and starts going up to +infinity for the rest of that graph. Okay, so left or right. I've got to have a -infinity on the left side of one of these and a +infinity on the right side of one of those. Okay? All right, here we go. Let's clear that function out. And we're going to type x cubed minus x. And I'm going to hit graph. Okay, does everybody see, and we zoomed in on this last time, it's going up, then it's going down, and then it's going up again, okay? I am going to zoom in, so I'm going to hit the zoom button. I'm going to choose number 2 to zoom in. And it pops up with x equals 0, y equals 0. I want to hit enter one more time because it's asking me where do I want to zoom in at. I want to zoom in at the origin, okay? So right here, it's going up, then it's going down, then it's going up. It's a little easier to see that way, okay? So right here, what would I call this point? It's a turning point. And then here's another turning point, right? So how many overall do I have? 2. Okay? Now, let's get specific about what kind of turning point it is. Is this a high point or a low point? That's a maximum, so it's a high point. And then the other one is a low point. It's a minimum. Now, is that my highest or lowest point overall of the whole graph? No, so these would be relative maximums and minimums, okay? All right, with my tail split, is there ever a highest value? No. With my tail split, is there ever a lowest value? No. All right, so let's go and let's calculate what these are. I'm going to calculate the maximum first because it's on the left side. I'm going to go to the left side of the mountaintop and hit enter. Does it matter where you hit enter? No. Then it asks me to go right bound, so I'm going to cross the mountaintop clearly to the other side, and I'm going to hit enter one more time. Okay? Now my maximum point is negative 0.58. 0.38. Okay, I'm going to round it to 2 decimal places if it doesn't tell me where to do it otherwise. That's a negative 0.58. I'm sorry about that. Okay, then I'm going to go calculate my minimum. Left bound, I just need to be on the left side of the valley. Hit enter anywhere. Again, guys, you've got to have your calculators in your hand. You've got to be the one doing this because you have a quiz on Friday, and any questions you ask about how do I do this on the calculator, I'm not going to answer them. You need to be practicing now, okay? I'm going to go to the right side of the valley, and then I'm going to hit enter somewhere. What do you notice about this?
It's the same as the other one, just positive.
Yeah, it's the same as the other one, except my values are just changed. Positives become negatives, and negatives became positives. Okay? All right. So I need my x values to help me write this. From left to right, what's my graph doing first? It's going up. So it starts with an interval of increase. It increases from negative infinity until I get to this maximum point. What's the x value of that maximum? Negative 0.58. And then right there, what does it turn and start doing? Going down. So negative 0.58 until I get where? Positive 0.58 to that minimum point. And then what does it turn and start doing again? Starts going back up. It went up, then it went down, and now it's going back up. So I have another interval of increase from positive 0.58 to where? To positive infinity. So I have multiple intervals of increase because at different points of my graph, it was going up, okay? Now, anytime I have multiple things like this, I'm always going to put this little U in there. That little U means union, and union means joining together. So these 2 intervals right here are intervals of increase. Okay? If I cannot see your eyeballs, that is my definition of sleeping. I need for you to have your calculator in your hand working with me. Do you understand? Okay? This is really important. I know we're coming off a long week of not having to do anything or having to think about anything. But you have less than 3 weeks to finalize what grade you're going to receive. Okay? I want you to do really well. It's not going to happen if you don't participate. Okay? All right, here we go. Let's go to k of x very quickly. And I'm going to type in x to the 4th power minus 5x squared plus 4. All right, I'm going to go ahead. I know that I've changed my window because I zoomed in. I'm going to go ahead and I'm going to hit zoom and number 6. Okay, and here comes a W-shaped graph. Okay? What are these 2 points down here on the bottom? They're minimums. Now, those are the lowest points over the entire graph. So those would be considered absolute minimums, right? But they're also minimums in that general area of a graph. So they also count for relative, okay? So these are both absolute and relative minimums. What about this point right here? Maximum. Is that going to be absolute or relative? Relative. Why? What about my tails? My tails on either side are going to go up forever. So is there ever going to be a highest point on that graph? No. Okay? All right, so let's trace the graph and let's kind of talk through it. I start out by doing what? Decreasing. Then I increase. Then I decrease. Then I increase. So there's 2 of each. Okay? I have to figure out where they're going to do all their little turns. And that's at their maximums and minimums. So let's start by calculating this minimum right here. So second trace, number 3. I want to arrow back to the left side of the valley and hit enter. I'm going to go to the right side of the valley and hit enter one more time. Okay, we've seen these before, okay? So I have a minimum at negative 1.58, negative 2.25. Am I going to need that y value to write my intervals? Nope. Okay, so we already know, because this graph right here is symmetric about the y-axis, we should automatically know that the other minimum is going to be positive 1.58, negative 2.25. Okay, so that's got both of my minimums taken care of. What I need to know now is what this maximum point is. Okay? So the maximum, I want to go to the left side of the mountain and hit enter. The right side of the mountain, I want to cross over the mountain. Look what it did to me again. Does everybody see that E? What is that going to be? 0. So 0, 4. Do I have any other maxes or mins that I'm going to need? No. Okay? All right, so I'm going to highlight these little values I'm going to need, okay? All right, to start out with, what was my graph doing? It was going down, so it's decreasing. So it decreases from negative infinity until I get to where? What's my first y value? I'm not y value, I'm sorry. What's the first value that I highlighted? Negative 1.58. And then at negative 1.58, it turned and started going up. How long did it go up? Until it got
0.
to 0. And then at 0, it turned and started going down again until I get to positive 1.58. And then at 1.58, what did it turn and start doing? Started going up again for the rest of my graph, so to positive infinity. Now I have two things with each. Does everybody see that the more turning points I have, the more intervals of increase, decrease I will have? Okay, so I'm going to throw in these little U's right here to join those two things together. Okay? All right, does that make sense? Okay? All right, so we're going to skip over this one just because those are really big numbers. Okay? Let's turn to the very, very back. Okay, back to kind of some of the same type of questions we dealt with earlier. It says make a conjecture, so make a hypothesis about the relationship of the degree of the polynomial and the number of turning points that the polynomial has. Recall that this is the maximum number of turning points of this degree can have, because these graphs are examples in which zeros have a multiplicity of 1. So right here, what do we know about the turning points? First of all, what do I call those turning points here? The turning points are where it's either a maximum or a minimum. Okay? So I would maybe say that the degree and the number of turning points is also going to give me some kind of indication of how many intervals of increase, decrease I will have. Okay? Tells us about the number of intervals of increase or decrease. Okay? And then putting it all together. Now that you have explored various characteristics of polynomial functions, you will be able to describe and sketch graphs of polynomial functions when you're given their equations. If I give you this function, okay, notice it's in factored form. We dealt with this not too long ago. Then what can you tell me about the graph of this function? Make a sketch of this function, describe its end behavior, and locate its critical points and zeros. So I'm going to sketch a coordinate plane real quick. Okay, I'm not even going to touch my calculator right now. Does everybody remember if there's like an exponent on it, what does that tell me about that graph? Okay, it's going to tell me where the x-intercepts are because it's in factored form. So I know right here.
Is that where it bounces off the graph?
Uh-huh. Right here, because of the square, there's going to be some multiplicity. So it will bounce off the graph. Okay? This is a rough sketch. Okay? Sorry about that. All right, so if I have x minus 3 equal to 0, what's that going to give me for my 0? 3. Okay, and if I have x plus 1 equal to 0, I'm going to get x equals negative 1. But I had a square on this one, right? So this is going to have the multiplicity with that one. So at -1, it's going to bounce off. It's also going to hit at 3. So I can sketch those zeros. Okay, what is the power? What is the degree of my polynomial here? How many
3.
x's am I multiplying together?
3.
3. I've got x squared because of this right here, and then I multiply it by another x. We did this before the break too, okay? X squared times another x. So this is going to be an x cubed function. Is my leading coefficient going to be positive or negative? Do I see any negatives that I'm multiplying? No. So I'm going to have a positive leading coefficient. My degree is odd. So tell me about my end behavior. How are my tails going to look? They're going to be split. On the right side, what's going to happen? Going up. So on the left side, it's going to go down. Okay, so let's see. If it goes down on the left side and up on the right side, and I know it bounces off here, couldn't I pretty easily figure out what my y-intercept is going to be? For my y-intercept, what do I need to be true about x? What's the x value on the y-intercept? 0. So if I plug in f of 0, that's going to be 0 minus 3 times 0 plus 1 squared. What's 0 minus 3? Negative 3. And 0 plus 1? 1. What's 1 squared? 1. And 1 times negative 3 is negative 3. So my y-intercept is 0, negative 3. So it's going to hit here. So it's probably going to come back up this way somehow. Do I know for sure that that's what that part looks like without putting it in the calculator? No. Okay, so it says make a sketch of the graph. We did that. Describe its end behavior. We did that. It says locate its critical points and its zeros. We already did the zeros. Okay, but let's take a look at my critical points. First of all, I know this is going to be a critical point because it's where it bounces. Okay, so I'm going to have a critical point. I'm going to have a maximum, not 0, negative 1, at negative 1, 0. All right, and I'm going to check in the calculator where the other one will be. Okay, so I'm going to type this exactly like I have it in my function. I have x minus 3 times x plus 1 squared. Oh dear. Let's see how I did. Not too bad. Does yours look something like that? Okay. All right, so the only other thing I need to calculate is this point right here. I need to calculate a minimum point. So second trace, number 3. I want to be on the left side of the valley, the right side of the valley, and hit enter one more time. So I've got, I know this fraction, okay, but I'm okay if we round it. So I'm going to say 1.67 and negative 9.48. okay? So that's kind of a lot of stuff to put together, but there are things that we can tell about my graph without ever having to touch the calculator. Yeah? Okay? All right. How you feeling this morning? You okay? I know. I'm sorry. So just to kind of run through the week, okay? We do have a quiz on Friday. The format of your quiz is going to be the format of the 2 practices and the quiz review that we do Tuesday, Wednesday, Thursday, okay? But for right now, you're about to get this critical points practice. Do you see how I have 10 blank graphs? All I want for you to do, okay? All I want for you to do is do part A in my directions. Graph each function as accurately as possible, okay? This was page number 15, okay? If you'll take one and pass it and get to graphing, okay?